So let's try solving this problem. Okay, so we have a second problem on special right triangles. Okay, so we have here Holden, a young architect, wanted to build a library for children and adults in their community. It has to be in front of their house so that he can manage it closely. So given on the illustration below, we have Holden's house. Okay, so this is Holden's house. And then we have the library here. Okay, and we have two right triangles. Okay, forming the library and Holden's house that are adjacent to each other or are next to each other. So we need to find the area. Okay, we need to find the area of the library, and also we need to find the area of Holden's house for this one. Okay, so for this problem, your main objective here will be to compute for the side measurement here. And this side measurement, it's not just an ordinary side measurement, it's the hypotenuse. It's the hypotenuse of these two right triangles that we have here on this problem. And since we're given here the side measurement 11 hectometers and 4 square root of 3 hectometers, we can create an equation using the Pythagorean theorem. A squared plus b squared is equal to c squared. We can write the legs. Okay, we can put the legs here. Since these are the legs of the right triangle, and we need to find the hypotenuse, we can say that 11 squared plus 4 square root of 3 squared should give us c squared. And since we know that 11 squared is just 121, and 4 square root of 3 squared, okay, so that's gonna be 4 square root of 3 squared, so that's 48. It's gonna be equal to c squared. So 121 plus 48, that should give us 169. And what's the square root of 169? So that's just equal to 13. So therefore the hypotenuse for these two triangles, for these two right triangles, is just equal to 13. Yeah, so therefore, if we're going to draw the triangle here, so this is 13, this is 4 square root of 3, and this is 11. And then we have another triangle here. We know that this is 12, and we can get the side measurement here by using the Pythagorean theorem again, but this time, okay, the hypotenuse is given. The hypotenuse will be 13 for this one, the one that we solve, and then we're given one of the legs, 12, and the other leg is missing. Okay, so solving for this one, this should give us a squared is equal to 169 minus 144. And what's 169 minus 144? That's just equal to 25. And therefore, the value of a, the value of this part here, that's just equal to 5 for this problem. Okay, so now that we know all of the side measurements, we can now get the total area. Okay, so first we need to get the area for the library. So the area for the library, that's just going to be 1/2 base times height. And since we know the base is equal to 11, and the height is equal to 4 square root of 3, we can compute that the area for the library is just going to be, this becomes 2 square root of 3, and that becomes 11 times 2, so that's 22 square root of 3 squared hectometers. So that's the area. This is the area for the library. So how about the area for the house? So that's gonna be 1/2 base times height, and that's just gonna be 1/2 times the base, which is equal to 12, and the height, which is equal to 5. And that's just 60. Okay, 12 times 5 is 60 divided by 2, so that's just 30 hectometers squared. So therefore, to get the total area, we have to add the area of Holden's house plus the library. And Holden's house is equal to 30 squared hectometers, and the library is equal to 22 square root of 3 hectometers. So therefore, the total area for Holden's house and the library is going to be 30 plus 22 square root of 3 squared hectometers. And if we're going to transform that into decimals, so that should give you 68.11. So there you go. So it's approximately 68.11 squared hectometers, the area of the total area for the Holden's house and the library is equal to 68.11 squared hectometers. And that's how we solved it for this problem.